In electric charges and fields and electrostatic potential and capacitance, all the charges are considered to be at rest. But in this chapter, that is current electricity, we consider all the charges to be in motion. Now let's discuss what happens when the charge is in motion. So when the charges are in motion, they constitutes an electric current. In everyday life, we use electricity in many of the applications like electric bulb, electric iron, etc. Now let's discuss about electric current in detail. Let's consider Q be the net charges of flowing and T be the time interval. So by this we can write Q is directly proportional to T, or we can say that net charges of flowing is directly proportional to the time interval. Now if we remove this proportionality, we need to multiply a proportionality constant so that we can write Q is equals to I into T. By rearranging this equation, we will get I is equals to Q by T, where I is called electric current. By this we can say that electric current is the ratio of flow of electric charges in a circuit. And the SI unit of electric current is ampere, which is also denoted by capital A. Now let's move to Ohm's law. It is discovered by G.S. Ohm in 1828. He considered a conductor and he connected that conductor with the potential, which has two terminals, one is positive and another one is negative. Because of this, there is a current flowing through that conductor. And by the observation, he stated that V is directly proportional to capital I, where V is electric potential and I is electric current. Or we can say that electric potential is directly proportional to electric current. And in simple words, we can say that as the electric potential increases, electric current flowing through that conductor should increase or will increase. Now, if we remove this proportionality, we need to multiply a proportionality constant, that is capital R. Therefore, we can write V is equals to R into I, where capital R is called resistance and the SI unit of it is ohm, and it is also denoted by this symbol. Now let's discuss what are all the factors affecting resistance. So resistance depends on the material of the conductor, length of the conductor, and area of cross section of the conductor. So to understand all these, let's consider a conductor with the cross section area A and length L. By Ohm's law, we can write V is equals to R into I. By this, we can write resistance R is equals to V divided by I. This is the resistance offered by the above conductor. Now let's consider another conductor which is connected to the previous one, which has same area of cross section and same length. If you connect any conductor in a series fashion, the voltage will change. And since here the length is doubled, the voltage will double. Therefore, we can write 2V is equals to R dash into I, where R dash is the resistance offered in the above case. So therefore, we can write R dash is equals to 2V divided by I. And we know that V by I is equals to R. Therefore, R dash is equals to 2 into R. By this, we can say that as the length is doubled, resistance is also doubled. And generally we can write as the length increases, resistance also increases. And mathematically it can be written as R is directly proportional to L, where L is the length of conductor. Now let's discuss what happens when the area of cross section increases. So let's consider a conductor and consider another conductor which is placed just above it, which has the same area of cross section and same length. And remember, when the conductors are connected parallelly, there is a division of electric current. In this case, the current will double. Therefore, we can write V is equals to R double dash into 2I, where R double dash is the resistance offered by the above case. That can be written as V divided by 2I. We know that V by I is equals to capital R. Therefore, we can write R double dash is equals to R divided by 2. By this, we can say that as the area is doubled, resistance become half. And generally, we can write as there is an increase in area of cross section, resistance will decrease. And mathematically, it can be written as R is inversely proportional to A. And previously, we derived R is directly proportional to L. By combining these two equations, we can write R is directly proportional to L divided by A. By removing this proportionality, we need to multiply a proportionality constant, that is rho. Therefore, we can write R is equals to rho into L by A. Substitute this in the Ohm's law. So therefore, Ohm's law can be written as V is equals to rho L by A into I, where rho is the resistivity. That's it for today. Thank you.